Alright guys, welcome to this page of the notes. Now what we're going to do is we're going to go ahead and start to take a look at matrix equations, right? And how we're going to use matrix equations to solve a system of equations. But let me quickly review what we've done so far in this chapter, because this has been a big chapter for us. We started off in the first 4 sections going through graphing, substitution, and elimination as methods for solving systems of equations. We then jumped into sections 5 and 6 where we were introduced to this idea of matrices and adding them, subtracting them, scalar multiplication, multiplying matrices, all kinds of really good stuff. And then what we did was we looked at Kramers Rule, this determinants of square matrices for solving systems of equations. This is just a fancy way of saying Kramers Rule. What we're going to get here now in this page of the notes is we're going to get introduced to the second method for solving systems of equations using matrices. And that's by writing a matrix equation. So let's just go ahead and jump right into this, get ourselves another method, yet another way to solve a system of equations. What I've got for you here is a system of equations. You should be used to this by now. We've been doing this for the last couple of sections. What I've got is two variables, x and y, in both equations. Since I have 2 variables, that means I need 2 equations. A, B, C, and D are the coefficients. E and F represent the constants, what these equations are equal to. Now, here's the way that it's going to work. What we're going to do is we're going to write a matrix equation that will look like this. Matrix A multiplied by matrix X is equal to matrix B. All right, now here's what each of those matrices are going to be. Let me slide this up a little bit. Matrix A. Matrix A is going to be your coefficient matrix, right? I take my coefficients A, C, B, and D, and I put those into matrix A, C, B, and D, right? So just pull the coefficients right out of your equations, put them into a matrix. No problem. We actually did that for Kramers Rule. Remember, we called it matrix C for coefficient. They've just changed the name here. Don't let that fool you. We're going to call it matrix A, but it's the coefficient matrix, all right? Matrix X. Let me do that one next since it's next in my matrix equation. So matrix A, the coefficient matrix, multiplied by matrix X. Well, matrix X couldn't be easier. Couldn't be easier. Whatever your variables are, X and Y, Z and T, U and V, W and Q, whatever your variables are, right? That's going to be your matrix X, all right? Make sure that you put them in the proper order. Whichever variable comes first in the equation goes in the top. Whatever variable comes second in the equation goes in the bottom. And X will be my variable equation, or my variable matrice. So, here's what I got. I got matrix A, coefficient matrix, matrix X, my variable matrix, and finally matrix B, using the only thing I have left over. I've got those 2 constants, E and F. Well, they're going to be your third matrix, matrix B, E and F. So, here's the way it would look. A times X equals B. Matrix A times matrix X equals matrix B. If I were to put it all together, my coefficient matrix multiplied by my variable matrix is all equal to my constants. Right? That's not so bad. Let me give you one here so we can try it together. You'll get a good feel for what this is going to look like here, right here on this one. We're going to go ahead and write our matrix equation for this guy. Remember, the matrix equation is matrix A times matrix X is equal to matrix B. Well, here's the way it works. Matrix A is the coefficient matrix. So that means I'm going to have 5, 6, 4, and 3. Right? Those are my coefficients for my variables, 5, 6, 4, and 3. So that makes my coefficient matrix. I'm going to multiply that by matrix X, which is my variable matrix. Well, my variables are X and Y. X comes first, it goes on top. Y comes second, it goes on the bottom. and there's my variable matrix. Now, both of those need to be equal to matrix B. Matrix B is going to be my constants, 1 and 3. And guys, it is really just that simple, right? I'm going to write my matrix equation by pulling the information out of the system of equations that you've been given in the problem. Now, here's what we're going to do with it. I have to solve this matrix equation, right? Because I'm trying to solve the system of equations. I need to solve for x and y. Here's how we're going to do that. I've got this matrix equation, right? And I need to get this guy right here by himself. Remember, this is matrix A. In fact, let me write it right below it, just so we have this as our visual cue. A times x is equal to B, right? And I need to solve this matrix equation for x. Well, right here is I'm going to show you how it's done. You won't have to do these steps every time, right? You just go straight to the finished product. Here's what we're going to do. A times x is equal to B. I need to solve for matrix X. Well, how do I get rid of matrix A? Well, this is what we looked at in the previous pages on these notes. If I multiply a matrix by its inverse, I get the identity matrix. So, I'm going to multiply matrix A by its inverse, which we just learned how to do. So we're going to find the inverse of matrix A, right? If we multiply these guys together, I get the identity matrix. Awesome, but here's what you got to remember about algebra. Whatever you multiply to one side of the equation, you have to multiply to both sides. So we're going to multiply that inverse matrix to the other side as well. Now, one other thing we mentioned previously in the notes is anytime you multiply a matrix, right, by the identity matrix, what do you get? Well, you get the original matrix back, right? I times x, it's like multiplying a number by 1. So I have solved for x, which is what I wanted to do, that matrix x. Here it is, I solved for it. And how do I find it? The inverse of A multiplied by B. So here's what I've done. I've just written it out for you right here. In order to solve for matrix X, right, you're going to find the inverse of A. You should recognize this formula. It comes from the previous pages on the notes where we find inverses, right? It's 1 over the determinant multiplied by the transformed matrix, and then matrix B, which is just your constants. Guys, we could talk about it all day long, but it won't set in until you do a couple of example problems. So head on over to the next page of the notes. I'll meet you guys there, and we'll solve a couple of these systems of equations.